Welcome to cryptography session. Today I am going to give an in-depth concepts of group. Here we already know that group is denoted as G. So G is denoted with Zn and the operation. So here dot is a binary operation. Normally we are performing addition or multiplication operations. So sometimes a group can also be called as abelian group, which should satisfy 5 properties. So those are closure, associative, identity, inverse, and commutative property. So if these 5 properties are satisfied, then the set is called as abelian group. Then from the group, we can able to calculate subgroup. So the definition of subgroup is subgroup share the same identity element and the number, that is the value which is present in group and subgroup are same. For example, if you take Z12 plus, we can able to write it as for Z12. So Z12, so number of elements are pi of 12. It will be written as 4 3s are 12. So 4 can be written as 2 squared into pi of 3. So pi of 3 is a prime number. Here 2 squared means 2 power 2 minus 2 power 1. So 4 minus 2 is 2. So 2 2s are 4. So the values of pi of 12 is apart from 0, the values are 1, 2, 3, 4 is not possible, 5, 7, that's all. 7, 9 is not possible, 10 is not possible, 11. So totally these elements are available in Z12. So if you take Z10, that means pi of 10, which will be written as pi of 2 into pi of 5. So it is a prime number, answer is 1. Pi of 5, 5 is a prime number, answer is 4. So totally 4 values are available. So Z10 contains 0, 1, 2 is not possible, 3, 4, 5, 6 are not possible, 7, 8 is not possible, 9. So these values are available. So in this thing 0 and 1 0, 1, 7. So these elements are available in Z12. So in this way we can able to give the notations for these subgroup options. Sometimes we can able to say the cyclic group. That means all the elements of a group can be formed with a generator. So if any generator is available in a group and that generator can able to produce all the elements of a group, means then that group is called a cyclic group. So how can we calculate those values? So we should do power operation. So here A is an element which is available in a group. K means number of times we should do the repeated operations. So how can we prove it? That means we just check whether is it 5 plus is a cyclic subgroup or not. So first we should write the set of elements. So 0, 1, 2, 3, 4. So the elements are 0, 1, 2, 3, 4. So I am writing the elements separately and do the power operation. So 0 power 0, 0 power 1. So maximum number of items are up to 4. So we should repeatedly use those values. So power means what is the operation which is given here. So it is given as plus. That means we should do repeated addition operations. So that is the meaning of power. So 0 power 0 is 0. Anytime if you add repeatedly the same value, the answer is 0. And these are all the answers. So the answers are same. So it is written in a set. And this set is called as subgroup. So my first subgroup answer is H1 is 0. And if you take 1, we can written as 1 power 1, 1 power 2, 1 power 3, 1 power 4 like that. 1 power 0 means 0 times if you add 1. So the answer is 0. 1 time if you add 1, 1. 1 time, 2 times if you add 1, 2. 3 times if you add 1, it is 3. 4 times if you add 1, the answer is 4. So you write the answers in a set. So the answers are 0, 1, 2, 3, 4. So you just check it out. The answer of Z5 and the resultant values are same. So this is the H2 group. So H2 is a subgroup which contains the same elements of group. So we can be able to write it as H2 equal to G. Like that, we can able to do the same power operations for the remaining elements. So 2 power 0, 0, 2 power 1 means 1 time if you add 2, 2. 2 times if you add 2, 2 plus 2, 4. 3 times if you add 2, 6, 6 mod 5 is 1. 2 power 4 means 4 times if you add 2, 8, 8 mod 5 is 3. So the set of elements is group. So H3 is also 3. And 3 power 0, 3 power 1, 3 squared, 3 power 3, 3 power 4. So 3 power 0, 0, it is 3, 6 mod 5, 1, 3 plus 3 plus 3, 9, 9 mod 5, 4, 3 plus 3, 6, 6 plus 6, 12, 12 mod 5, 2. So H4 answer is also group. Then if you do the same addition operations for the number 4, the values are, it is 0, 4, 4 plus 4, 8, 8 mod 5 is 3, 4, 3 times 4 means 4 3s are 12, so answer is 2, 16 means answer is 1, so H5 contains also the group as G. So totally only 2 subgroups are available. The first subgroup is 0 and the second group is G. So what is G? G is nothing but Z5 plus. So what are the elements of this group? 0, 1, 2, 3, 4. So you just check the subgroup values. So H1 is called as a subgroup because it contains the same element of a group. So H1 is called as a subgroup. And here generator means by using an element 1. So here I am taking A is an element. So I am doing A power K value. So K value is from 0 to 4. And we can able to produce all the elements. So here 1, 2, 3, 4 are called as generators. So the elements 1, 2, 3, 4 are able to produce the same elements of all the elements of a group. So these are generators. So if a group contains at least one generator, then that group is called as cyclic subgroup. So here in this Z5 plus is a cyclic subgroup by proving this calculations. So once again I repeat the definition for cyclic subgroup. If a subgroup of a group can be generated by using power of an element. So here, so this is the element. So these elements are applied with power of element. Then subgroups are formed. Here 2 subgroups are formed. Then that is called as subgroup. So I will give an exercise to you. There are 2 different exercises are there. Here Z6 plus and they will give the subgroup values. We just only check whether these subgroups are able to form a cyclic subgroup, which means that we just check whether at least one generator is available in this Z6 plus or not. So here the subgroup answers are given. But if you take the second problem, in the second problem we only check the power values for these 4 elements 1, 3, 7, 9. For this 4 elements only you just do power operation. Which means what? 1 power 1, 1 power 3, 1 power 7, 1 power 9. Like that 3 power 1, 3 power 3, 3 power 7, 3 power 9. 7 power 1, 7 cube, 7 power 7, 7 power 9. 9 power 1, 9 cube, 9 power 7, 9 power 9. Because only 4 elements are given. So you just do the answer with the mod operation of 10. Just to check the subgroup values. So you write the subgroup answers as H1, H2. So you just try to find the answers. So the resultant values are written as H1, H2 like that. So we just write those values. So if any subgroup is able to form a group means it contains some generators. So we just check whether 1, 3, 7, 9. So any of these 4 elements is a generator. So if any generator is available in this group, then this Z10 cross is taken as a cyclic subgroup. So here power means we should do multiplication operation because cross is given. So 3 power 3 means we should multiply 3 by 3 times. So 7 power 7 means we should multiply 7 by 7 times because multiplication operation is given. Like that we can able to check the cyclic subgroup notations. Thank you.